You think you understand what you're really asking when you say, why do magnets repel each other? But most people don't. And until you see why the question itself is flawed, every explanation will leave you unsatisfied, including this one. Let me lay it out clearly. Take two magnets and bring the north poles together. Feel that firm, invisible resistance in what looks like empty space. Your instinct is to want a simple comparison. It's like two springs pushing back, or like hands shoving against each other, or something else from daily life that already makes sense to you. Here's the hard truth. There is no such everyday equivalent. I'm not dodging the question or being deliberately obscure. Magnetic repulsion is a fundamental interaction, one of the basic building blocks of reality. There's nothing more primitive to reduce it to. Demanding a simpler explanation for electromagnetism is like asking someone to define addition without referring to numbers. It simply doesn't work that way. You might be thinking, but I've heard about magnetic fields and spinning electrons. Yes, those are excellent, extremely accurate descriptions. They tell you precisely how the force operates, how to predict its strength and direction. But they don't answer the deeper why does this force even exist? And recognizing that distinction is crucial. Try this right now. Press your palm firmly against your desk. Why doesn't your hand sink through? Most people start with because the desk is solid. That's just restating the observation, not explaining it. Dig deeper. The atoms are densely packed, closer, but still not enough. Atoms themselves are overwhelmingly empty. Scale one up to the size of a football stadium. The nucleus would be a tiny pea in the middle, while the electrons are specks scattered near the distant stands. Virtually everything in between is vacuum. So your hand and the desk are both almost entirely empty space. Yet they refuse to interpenetrate. Why? Because of the electromagnetic repulsion between the negatively charged electrons in your skin and those in the desk. Like charges push each other away. Billions upon billions of these tiny repulsions combine into the sensation we call solidity. Here comes the part that usually unsettles people. That exact same force, electromagnetic repulsion between like charges, is what makes the two north poles of your magnets push apart. Not similar, not analogous, identical. So why does one feel completely natural while the other feels strange and in need of explanation? It's simple psychology. You've spent your entire life pushing against tables, doors, floors, toys. Your brain built an entire intuitive model around those close-range electromagnetic interactions. By toddler age, solid things don't pass through each other, felt obvious and required no further thought. But with magnets, there's a visible gap. You can see straight through the space between them, even slide paper in there. That distance makes it feel unnatural. Yet physically, it's the same mechanism, just acting over a larger scale. The only real difference is familiarity, not physics. You might now think, surely quantum mechanics or QED gives the ultimate why. No. Quantum electrodynamics is arguably the most successful theory in history. It predicts electromagnetic phenomena to 12 decimal places in some cases, and experiments match perfectly. But QED gives you exquisite rules for calculating interactions via virtual photon exchange between charges. It describes the force with breathtaking precision. It does not reduce the force to something more basic or tell you why the universe has this particular force in the first place. It stops at this is how charged particles behave. Consider another chain. Why does ice float? Lower density. Why lower density? Open crystal structure from hydrogen bonding. Why that arrangement? Quantum properties of electrons in H2O. Why those properties? Solutions to the Schrödinger equation plus Pauli exclusion. Why do those rules hold? Because they match every experiment we've ever done. You quickly reach the same bedrock. Fundamental laws and forces that simply are. We describe them, test them, use them, but we don't derive them from anything deeper. The real issue with why do magnets repel is that you're not primarily seeking facts. You're seeking comfort, a story that ties the unfamiliar back to something already intuitive, so the confusion stops. But the honest answer is magnets repel because of the electromagnetic force, which is a fundamental feature of our universe. There is no deeper narrative waiting underneath, just precise mathematics, rigorous experiments, and predictive power. And here's the perspective shift most people miss. Magnets aren't some exotic outlier in an otherwise normal world. Everything macroscopic is electromagnetism in disguise. Chemical reactions, electron rearrangements via EM forces, light reflecting off a mirror, EM waves interacting with matter, your vision, EM radiation triggering retinal cells, your phone or computer, electrons flowing under EM control. Gravity is ridiculously weak, about 10 thou creep 6 times feebler than EM at atomic scales. The strong and weak nuclear forces only operate inside nuclei, so almost every force you experience day to day is electromagnetism. Trying to explain magnetic repulsion using something normal is circular because the normal stuff is also electromagnetism. To help visualize, here are some clear illustrations of the magnetic field lines. When two like poles north-north face each other, the lines show how the fields repel and push the magnets apart. And for the atom emptiness analogy that makes the desk hand example click, what is an atom? Like us, mostly empty space. It seems vertical bar. Fleet. The technical summary I can give you. Permanent magnets arise from aligned magnetic dipole moments, mostly from electron spin and orbital motion. Two like poles create a high-energy magnetic field configuration. Nature favors lower energy, so the system pushes the magnets apart to reduce stored energy. That's the mechanism. Deeper questions lead to moving charges, quantum spin, the Dirac equation, relativity plus quantum mechanics, and eventually back to these laws match reality when tested. Physics doesn't begin with grand philosophy and deduce the universe. It starts with observations, builds mathematical models that fit the data, and refines them through experiment. When a model predicts new phenomena correctly, as QED does spectacularly, we call that understanding. And by that measure, we understand electromagnetism extraordinarily well. We use it to build motors, MRI scanners, particle accelerators, hard drives, and more. Your everyday intuition was shaped by survival needs, not by grasping quantum fields. When reality clashes with that intuition, wave-particle duality, time dilation, action at a distance, you can either cling to the discomfort or expand your mind through math, problems, and experiments. Most physicists choose the latter, so next time you feel two magnets repel, shift from why to how. How does the force scale with distance? How much stronger is it than gravity here? How would you compute it? How can we harness it? Those have clear, elegant, useful answers. The philosophical why you're chasing stops because we've hit the foundation, and that's not a defeat. It's where real power begins. The universe isn't obligated to feel intuitive, but we can still master it.